Hi, my name is Zack, and this is my presentation for the measuring time reaction project. So first I will start on telling you how I make the time strip. I found a lot of free cardboard in source room from our school, so making it was pretty convenient. The next steps is to make the reading data for the reaction time strip, which I use Excel to create, and to find time I use the second equation in our for kinematic equation, which is delta x equal initial velocity times time plus 1/2 of the acceleration times time square. So to put it in Excel, I use this quadratic formula to find x, which is the time, and for the different d value, they have the different initial velocity. So I use the third equation to find there's initial velocity, and then put it back in this second equation to find the second thing I want to talk about is the error and accuracy. I want to talk about this first before showing you the data, because the relative accuracy will be in the data too. So it's better if we talk about this first. So the error might be from plus or minus 15 microseconds. There's three sources of error that can be found in our experiment project. They are in the setup. The subject might hear what I'm doing. I did give him like a headphone over his head, but it might not work that well. And there's also error in the RT strip length, because it's hard to choose the size of the cell, so it's 5 millimeters increment. So the strip can be a little bit inaccurate. So the third one is error in eye level. Maybe the subject might read his reading wrong from 1 to 2 microseconds based on his fingers. So that's a source error, and knowing source error related to the accuracy of the test. The first subject is Hung. He's Henry. So he's my first subject, and this is the mean from the data for each d value, standard deviation, the lowest and the highest based on the error, the range of error plus or minus 15, and the relative error is the error divided by the mean, which is here. So it's like 7.9% most of the time. And so let's look at the relative error, which is 100% minus the relative error. So it's fairly accurate. This doesn't vary a lot between the d value. The second subject is Tan. He's a hostmate living with me, so it's pretty convenient to test him too. And this is his data with the mean, standard deviation, relative error, relative accuracy. This is his third subject. It's Quan, one of my friends. Fourth subject, Hi, one of my friends too. And yeah, the last subject is also one of my friends. So then we come down to the question: does the accuracy of or the relative accuracy depend at all whether subject reaction time is short or long? Well, yes, it does, because the absolute error is the error over the actual data, which is the mean. So where our error is a fixed value and our data, the mean, varies from people to people in each d value. So the smaller the data is, the reaction time, the bigger the error will be. So it does depend on whether the reaction time is short or long. The longer it is, the more accurate the result will be. The second question is: does the accuracy or relative accuracy depend on the d value? Well, if our data is consistent between 0 millimeters, 5 millimeters, the d value, then the d value shouldn't be the factor. If you can see in most of the data, the 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 relative accuracy between the data didn't vary that much. It's about 1% in difference. So because it's still data from different time and different tries, it can't be the same. So this a really small change. So I would say that the d value didn't affect that much. Next would be the elevator question, which is when for a going if the elevator is going up at a constant velocity of 5 meters per second. So the reading would change because absolutely change because of the extra 5 meters per second initial velocity. So our equation is delta x over initial velocity times time. So there the velocity does matters in our equation. So if we change it, it will affect the data. So and we will be keeping it in as a negative velocity because because the delta x is downward. So and we also keeping the gravity as a positive value. And so for elevator to go up, which is in the opposite direction, anti-parallel to our delta x, then it must be a negative value. So the way to fix the equation is to minus 5 into the initial velocity. So minus 5 in this velocity value, and then find t, which is fairly easy. And so for b, going down as constant velocity of 5 meters per second. Like for a, the reading will change because the initial velocity does matter, and the 5 meters velocity going down would be the positive value because of our system, which is delta x in the delta x is a positive direction. So for it to go downward at the parallel to our delta x would be positive. So add 5 to our initial velocity value would fix the problem. It's to the quadratic equation. So for C, going up at a constant acceleration of 5 meters per second square, the reading will change as well because in equation 2, in the 4 kinematic equation, it does consists of an acceleration, which is when we put it 9.8, but here we also have the constant acceleration of the elevator in 5 meters per second up. So like the 4a, because the elevator is going up, the value of the acceleration should be a negative value. So if we minus 5, let's type on here, minus 5 meters per second to our 9.8 meters per second square, which is the gravitational acceleration in our equation, then we would get the accurate data. Check here. Yep. 4D. So in this situation, the elevator is going down as constant acceleration, so it's going in the same direction as the force of gravity. So the acceleration would be a positive acceleration. So here, yep, same direction with the delta x. Okay. So by adding 5 meters per second square to our 9.8 meters per second square, which is the Earth gravitational acceleration, it would give that as the accurate reading of the data for the data. So going up here again, I think I will explain clearer how I compute the data in Excel. So there's a command in Excel is to find the average. So by putting equal, then the word average, equal, then average, then parenthesis, then select all the cell here from the first one to 10th data. The Excel will compute the average, which is the mean for us. And there's also command called standard deviation, which is we find given standard deviation of the data if we select from the first one to the last one, and the other one is very easy. So yeah, so I think this is the all of my PowerPoint. So thanks you for listening, and have a nice day.